Find the absolute maximum and absolute minimum values of the given function subject to the condition that the coordinate pair xy is on the circle x squared plus y squared equals 25. This is a circle centered at the origin with radius 5. And the function x squared plus 2y squared minus 8y minus 1, the graph of that in xyz space is an elliptical or elliptic paraboloid. The cross sections are ellipses. So we would like to know the maximum and minimum values of this function as the coordinate pair ranges on this circle. And we'll use the theory of Lagrange multipliers, which says that the maximum and the minimum will occur when the gradient of f is parallel to the gradient of g, where we're going to consider this equation here. If we write this as g of xy equals x squared plus y squared minus 25, and that would equal 0. So this is a level surface, a level curve. This is a level curve. So we want the gradient of this level curve. It's not important that we put the 25 on the left side. It's just important that the right side is a constant. So move all variables to the left so that the right side is a constant. And then this function is g of xy. If you didn't put the constant here, whether the constant is here or not, it won't change the gradient, because the constant's not going to contribute to the gradient, as we will see in a moment. So the gradient of f, here's f. So we have gradient of f is equal to the vector f sub x comma f sub y, and f sub x here is 2x, and f sub y is 4y minus 8. So that's our gradient of f. And the gradient of g is 2x, that's g sub x, 2x, comma g sub y, 2y, and the constant contributed 0. The derivative with respect to x is 0, and the derivative with respect to y is 0 of the constant. Okay, so those are our two gradient vectors, and we want them to be parallel to one another, which means one of them is a multiple of the other. So we'll say the gradient of g is some multiple, so that's some real number, lambda. That's the standard letter in Lagrange multiplier problems. So the gradient of f, 2x comma 2y equals lambda times 2x 4y minus 8. So let's look at the components. 2x on the left is equal to the first component on the right is distributing the lambda. It'll be 2 lambda x. And the second component's 2y equals 4 lambda y minus 8 lambda. Or maybe it's just better to write that one with lambda times 4y minus 8. The first equation, 2x equals lambda times 2x. So either lambda is equal to 1, or if lambda is not 1, then the only other possibility is that the x itself could be 0. If x is 0, then no matter what lambda is, this equation is 0 equals 0. And of course, if lambda is 1, then we get 2x equals 2x. So if lambda equals 1, then x can be anything. And the other possibility is that x equals 0, in which case lambda can be anything. So first, let's look at x equals 0. If x equals 0, then since the point xy is on the circle of radius 5, then that means that y squared x squared plus y squared has to equal 25, and x is 0, so y squared is 25, which means y equals plus or minus 5. So we have potential max and minimum at the points 0, 5, and 0, negative 5. Now let's consider lambda equals 1, and what does that tell us about y? If lambda is equal to 1, that's a lambda. If lambda is equal to 1, then 2y is equal to 4y minus 8. And that's going to tell us 8 is equal to 2y, so y is equal to 4. And again, the point xy has to be on the circle, so x squared plus 4 squared has to equal 25. So x squared is 25 minus 16 is 9, so x is plus or minus 3. So we have two other points, 3, 4, and negative 3, 4. So at one of these 4 points, we will find the absolute max and the absolute min. So we now just have to plug them in, plug these 4 points into the function and see what happens. See which one gives us the largest output and which one gives us the smallest output. Let's do the 3 fours first. Whether x is plus or minus 3, this will become 9. And so these two are going to give us the same number. We're going to get 9 plus 2 times 4 squared. 4 squared is 16, double that is 32. Minus 8 times 4 is also 32. And then minus 1. So this is 32 minus 32, 9 minus 1. So the function is equal to 8 at both of these points, 3, 4, and negative 3, 4. So let's keep that one in mind. And how about 0, 5? If x is 0 and y is 5, then we get f of 0, 5 is equal to 0 plus 5 squared is 25 times 2 is 50 minus 8 times 5 is 40, and then minus 1. And this is 10 minus 1 is 9. And if we try f of 0, negative 5, x is 0, y is negative 5. Negative 5 squared is 25 times 2 is 50. And then plugging in negative 5 will give us negative 8 times negative 5 is plus 40. And then minus 1 gives us 99 minus 1, which is 89. So of these 3 values, one of them is the maximum and one of them is the minimum. So the maximum, the absolute max, is 89, and the absolute min is 8. So there we have it.